Welcome to Algebra Skills. The purpose of this class is to introduce you to the basic algebra skills to ensure your success in higher math classes. This can be anywhere from algebra to calculus to trigonometry. The list goes on depending on how much math you will need in your major. Algebra encompasses evaluating and manipulating algebraic expressions, solving equations, and the relationship between equations, tables, and graphs, to name a few. These are many of the concepts we will look at over the course of the semester. Before we begin our study of algebra, let's review the cornerstone of mathematics, which is arithmetic. Arithmetic deals with the properties and manipulation of numbers. By manipulation, we mean our basic operations of adding, subtracting, multiplying, and dividing. Module A is intended to review these properties and operations, as well as provide you insight of when we will use and expand these concepts later in this course, as well as future math classes. Before we begin, please print the necessary packet of notes so that you can go ahead and fill in any definitions, procedures, and examples. These presentations are designed to assist you in taking notes, as well as allow you to pause, rewind, and repeat the lecture or parts of it until you completely grasp the concepts presented. During or after watching these videos, please make notes on any material that you either struggled with or felt wasn't presented in a manner that made sense, so that we can address these topics in more detail in class, and or make changes to the videos to improve your experience in this current course, and for future students. So let's go ahead and begin with a review of numbers and different number systems. Upon completion of this section, you will be able to define and provide examples of the following number systems: the natural numbers, the whole numbers, integers, rational numbers, irrational numbers, and real numbers. In terms of our number systems used in mathematics, the first one that we are introduced to is the natural numbers. The natural numbers start at 1 and increase 2, 3, 4, 5, etc., etc. Sometimes we refer to these as the counting numbers. In terms of ancient civilizations, or in terms of history, the natural numbers, these were the numbers that ancient civilizations worked with. And one thing to note is that just about every single ancient civilization only had whole numbers. They developed fractions, but fractions are very relevant to real life. But one of the important things to consider is that there were no negatives. There was no zero. Irrational numbers, we'll talk about that later. But natural numbers, these are the nice numbers that we work with. Now, as we progress through history, we have to start including other number systems. So the next number system that we have is the whole numbers. When I talk about number systems, I like to talk in terms of, let's start with prehistory. Prehistory, the caveman walks out, he sees woolly mammoths. They can be counted. These are our natural numbers. Now, eventually, we all know that the woolly mammoth died out, and we had to come up with a concept of zero. Now, an interesting thing to note is that there is one ancient civilization that recognized zero as a number, and that was the Maya civilization. So, go Americans. But that is our next number system, the whole numbers. The whole numbers is basically the natural numbers plus zero. Now, when we start getting into more complicated civilizations, well, we develop the integers. The integers represent borrowing, having, owing. I like to consider this kind of our banking example. And so the integers consist of the whole numbers as well as their opposites. If you were in math class in high school, if you took a math class in high school, one of the things that your math teacher might have had was they probably had the number line as a border around the top of the room. We're talking about the integers when we talk about the number line. Now, natural numbers, whole numbers, integers, these are all very easy to write out. When we get to rational numbers, we have to kind of change our mentality. And we can't write them all out. We can't list them all out like we did with the previous examples. Rational numbers, these are numbers that can be written as fractions of integers. Now, rational numbers includes not only the integers and thus the whole numbers and the natural numbers, but they include fractions. They include terminating decimals. These are decimals that stop at some point. And repeating decimals. These are decimals that have a pattern that repeat forever. The next number system we have is kind of the red-headed stepchild of the real numbers, which is the irrational numbers. So far, note that natural numbers are whole numbers. Natural numbers and whole numbers are integers. Natural numbers, whole numbers, integers, and rational numbers. Irrational numbers, on the other hand, are kind of this side category. These are numbers that are not rational. If you were to write them out in decimal form, they have non-repeating, non-terminating decimals. So what is an example of an irrational number? Well, this is going to be our square roots of numbers that are not perfect squares, our cube roots of numbers that are not perfect cubes, etc. We also have pi and multiples of pi. These are some of the examples we will see this semester, but note that that is not a comprehensive list. There are other examples that you will see in future math classes. Which brings us to the real numbers. The real numbers is a combination of rational and irrational numbers. The numbers that we will work with over the course of the semester will be in the real number system. So you're probably thinking, well, okay, that has to be everything. And in fact, it's not. We will work with real numbers in this course, but as you progress to higher math classes, you might learn about numbers that are called imaginary. Imaginary numbers, how do we obtain them? What are they? They are the square roots of negative numbers. The combination of the real numbers and the imaginary numbers are referred to as the complex number system. Now, as I said, this is kind of just a little side note. This is not anything that you need to know for this class, but just know that there are number systems that exist beyond what we will be working with in here. One way to think about the real number system is to consider it like a map. If you think about the city of Las Cruces, we can think of it as being in Doña Ana County. Both of those are in New Mexico. All three of those are in the United States of America. And all of that is in North America, along with Mexico. If you think about the laws of the United States of America apply to New Mexico, apply to Doña Ana County, apply to the city of Las Cruces, whereas they don't necessarily apply to Mexico. So we can kind of think about it as being a little bit of a separate entity. The same thing holds true when we talk about the real numbers. The natural numbers, like Las Cruces, are contained within the whole numbers, which would be like Doña Ana County. Both of these are contained inside the integers, like New Mexico. All of these are contained in the rational numbers. All of them are contained in the real numbers, and we have this little subcategory off to the side, which is the irrational numbers. So one thing to keep in mind is that you can think of it as a map. In terms of the rational numbers, another way that you can think about it is like nesting dolls. They each fit inside of each other. Let's look at the following example and determine which numbers belong in each number category. One thing to keep in mind when we do this, not only do we want to look at the number itself, but you also want to consider, can it be written in another form that would classify it as one of the given examples. So, for instance, if we want to start with the natural numbers, you may be thinking that none of these look like natural numbers, but remember we want to consider ones that simplify to a natural number. For instance here, square root of 81. The square root of 81 is equal to 9. And since 9 is a natural number, the square root of 81 is a natural number. Now let's talk about the whole numbers. One thing to keep in mind when we do this is that we keep everything that was in our previous category. Square root of 81 is 9. 9 is a whole number, and so we can keep it. We also want to add any new numbers that could be whole numbers. For instance, 0. Remember that the only difference between the natural numbers and the whole numbers is that the whole numbers include the number 0. That's it for the natural numbers. So let's move on to the integers. Same thing, I want to keep all of my previous numbers. So square root of 81 is 9. 9 is an integer. 0 is an integer. And now, do we have anything else that we can include? Well, we can include negative 7. Negative 7 is the opposite of 7, which is a natural number, and therefore it is an integer. Alright, so now let's look at the rational numbers. Again, I want to keep all of the numbers that I've been looking at so far. So we have square root of 81 is rational, 0 is rational, negative 7 is rational. The reason that we can consider these as rational is I can always go ahead and put it over 1, and it's a fraction. And remember that rational numbers just mean, can I write it as a fraction? So we have our starting numbers, and now we want to include any new numbers. So the first one we can include is negative 3/4 because it is a fraction. The second one that we can include is 0.6 with a bar over it. If it has a bar over it, it represents a repeating decimal. And remember that repeating decimals are considered rational. We're not going to get into it, but what would it equal as a fraction? Basically what you do is you take the number being repeated and put it in the numerator with a denominator of 9, 99, 999, depending on how many digits are being repeated. The last one that we can go ahead and include is 7.3. 7.3 is a terminating decimal. If I wanted to write this as a fraction or as a mixed number, this would be 7 3/10. So that takes care of our rational numbers. And now we want to go ahead and jump over to our red-headed stepchild of the real numbers, which is the irrational numbers. Now this is the only category where we do not keep everything that was in the previous set. So what have we not looked at yet? Well, the ones that we have not looked at yet is the square root of 5. That is an irrational number. And we have not looked at pi. Pi is an irrational number. And that takes care of every single number that is in our set. So what are the real numbers? Well, I don't feel like listing them all out again, but in this class, the real numbers, it's always going to be any number that we're working with. So when will we see this again? When solving in problems in mathematics, it's always good to know what you're working with, so you can know how to report your answers. Most of the problems we will work with in this class involve integers, but we will also be working with fractions, decimals, and roots, among other types of numbers. The reason that I say you always want to know what you're working with is if you have problems involving decimals, then you want to report your answer as a decimal. If you have problems involving fractions, it's always standard to report your answer as a fraction. If you have problems involving mixed numbers, it's standard practice to report your answer as a mixed number. As mentioned previously, there is a number system beyond the real numbered system known as the complex numbers. Once you officially learn about it, you will have to check what numbers you are working with when solving problems. When you are in the real number system, your solution would be no real solution. Whereas if you're in the complex number system, then you do have to go ahead and find a solution if it's not real. So now, for homework, I want you to try the following problems on your own. Bring them to class. We will go over your solutions and answer any questions. Also, if you look down at the bottom of the screen for this video presentation, there is a comment section. If you have registered for the Explain Everything app or have a Google account or similar account that you can log in with, you are free to leave comments so that I may know exactly what it is that you struggled with. Again, we will go over that in class next time. So, before we come to class next time, please try the following problems on your own and bring your solutions to class, as well as any questions that you have. We will start with these at the beginning of class before continuing on to other material.